All right, welcome back. Let us finish up finally these slides on classes. The last stuff we learned was how to make like really fancy programs where we split up, right? Split up all of our implementations across separate files. We made libraries. It was very nice. And then we learned about const and getters and setters, public and private, all that fun stuff. And now what I want to start with is let's finally come full circle. Let's talk about that counter example that I showed you right at kind of the start of class, right? At the start of the semester. We can finally make that. All right, we did get halfway there with functions. We made this functions version of a counter library, but you only got one counter out of it. Like you can initialize your one counter, increment your one counter, decrement your one counter. Let's make a class so that we can have as many counters as we would like. That is the beauty of classes and object-oriented programming, right? So let's make our counter library using classes now. All right. And so when I make a counter C, I could then go along and make a counter C2 if I wanted. But what should every C object have? Now is the question for us. So I want to kind of keep it like the library for the functions that we had before. We should definitely have our member variable that is the count on our counter, right? So let's definitely have that, count, if I can spell count. So we need that. And when you say counter C semicolon, it starts off garbage. We'll have to fix that in a second. We made an init counter function for that before. I think a good idea then would be let's make an init member variable, or not member variable, init member function. So that's part of every C object has an init member function, an inc, a dec, all those fun things. And like we should always remember to call init first. So that'll make sure that we've got all the values that we need in it. So like c.init, we want to always call that first before we do anything else, because that'll make sure our count is like set to 0 or something. And then like c.inc after that. We'll do all, and then that should make the count 1. That's what we want to do, right? So we got all those fun things. We would like to have a getter, right, for our get count. We kind of already did that before, didn't we? And then maybe like a reset method that just like immediately makes it whatever count we want it to be. But init is supposed to be like something we call just once and never again, kind of. Right, to initialize, and then it's done. So yeah, let's make that happen. Where do I want to go? Let's make a new file called, let's just make it all in one file. We'll be lazy. But I'll still do it separately. I'll declare the class, implement the class in a different place. But here's kind of how I want to use my my counter. I want to be like counter C, and then c.init to initialize it. And then I could be like c.inc a bunch of times, like 1, 2, 3, and then now, like the count inside the counter should be 3. c.getCount will give that back to me. Excuse me, that's how I want to use it. Okay? And then I could call other things like dec, and there's plenty of other operations that I want to do, so maybe let's just do them. Let's have it all ready. Here's all the things I want to be able to do to my counter. So it's 3 right now. If I dec it twice, now it's back down to 2, 1, right? It should be printing 1 here. And then this reset thing, I want to just like set it to some new count. So I can do this. I can say something like c.reset it to 42, and then inc it one more time, so now it's 43. So now the count should be 43 for sure, right? So these are the kinds of things I'd like to be able to do. And now let's make the class so that it can happen. Class counter. And so I've got public stuff and private stuff. What is my one private thing for sure is my member variable. So that should be int count. That's what I'll call it. So every counter object has a count secretly inside of it, but it is private. Nobody gets to see it other than us, the implementers. And then I'll do all these guys. Init, reset, inc, dec, all that fun stuff. Boop. So here, init is going to be void. Init just like that. Void reset gets an int new count. Void inc, void dec, and then int get count. It's got to give back the int that is our count. I think that is right. So that's the implementation, or sorry, the declarations of the class. And I guess a good question right now is, should any of these be const methods? Init's got to mess with the count, reset's got to mess with the count, inc dec, same idea. Get count though, every getter should be const. There. So now this is the correct declaration of everything. Now let's go and implement it down here. So these look like normal functions, and we have to tell C++, no, they're not. They're actually methods in the counter class. So these just look like functions right now. We have to say, no, this is counters init method. This is resets init method. I have member variables I'm allowed to talk about now. These are not just normal functions laying around. It's counters get count method. And then, like, it wasn't even happy with the const before I said that, because normal functions cannot be const. So okay, let's implement all these. So let me, I think I should split screen so that you can see the declaration, and then here's the implementation. So init, just like zero out the counters count. Reset, set the count to be whatever new count is. Inc, count plus plus, take my count member variable, increment it. Same with dec, it's just in the opposite direction. And then get count should return whatever my count is right now. Okay, I think that should do it. Yeah, that's everything. Those are the implementations, and then here down in main, I'm using my counter object. And so this is just a very complicated program that prints 3, because 0, 1, 2, 3, there it is. 2, 1, prints 1 after that, and then 42, 43, that's the new final count for C. Do you see it? I think that is it. That's pretty nice, isn't it? And then, let's see, what else? The whole point of making this as a class, rather than like a library with functions only, is we can make multiple counters. Watch. I can do something like this. I can make a counter D, and like initialize that D dot init, and then D dot inc, and then like use that and get the get count. So that's all the fun stuff that I can do. All right. So that's the whole point of all this. Let's see. Yeah. So that's what I wanted to say for this slide. What else? What's next? I guess I just want to kind of show you what's going on under the hood secretly, because I've been drawing it like this. I've been saying like, all right, every object gets its own init method, gets its own inc dec. Like it knows how to act on that one object. So like if I made a counter D, like it has its own init, has its own inc. That is true, but not really. All right, so let me show you the truth now. So secretly, every method in C++, for efficiency's sake, all these methods, they really are just secret functions. They're just called in a fancy way, and C++ helps out with that. All right, so every method is secretly just a function, and it gets a secret 0th parameter, or negative first parameter, however you want to think about it. It gets the object itself. All right, so actually, what happens when you say this, when you say c.inc, the way it knows to mess with C and not like D, whereas like you could have said d.inc, right? Something like that, if I can write the letter D. The reason it knows the difference is you said D dot rather than C dot. You see it? So really, secretly, the object itself is an argument to the inc method. That's how it knows which object to act on. So secretly, this gets turned into a call that looks like this. It turns into counter. The C++ is doing this for you as it's compiled. It's like turns this into a function call called counter : inc, and then C is a secret parameter. All right, it's a secret 0th parameter, and the name of that parameter, we call it this, short for this object. What is my current object? So this is really, it's actually a keyword in C++ that I'll show you later, but like that exists. All right, so that's the secret this parameter. This gets turned into this when you compile. And that's how it knows, inc knows to act on C rather than D or E or F, okay? And that lets you get away with only having one implementation in the code somewhere, because secretly there's a 0th parameter telling you which object you're acting on. So that's good for space efficiency too. Not every object needs its own copy of the method or something like that, okay? So that's secretly what's going on. And so let's say here I was in main calling this. And I made my C, and I said, like its count was 0. I initialized it, the count was now 0, and I said c.inc. Really, when I run this line, what's happening is it's jumping up to, like, inc is really just a secret function that's being called in a fancy way. It's really like its declaration is something like counter : inc with a parameter called this, all right? That's what it's taken. That's your secret 0th parameter, all right? Your secret 0th parameter, and that's the name of the object itself. That's where it's going. Secret 0th parameter, even though there wasn't any parameter. Even though there really wasn't one, C is secretly one of them. All right, that's the trick. That's the trick, and that's how it knows to mess with things. And so, where do I want to go with this next? Dun, dun, dun. So yeah, let's talk about the code. So here I am, like init. Now I'm on inc. It's really counter : inc, and it's being called with the counter C. And then whenever you say something about your own member variable, now the whole reason this works now, the whole reason this count plus plus is messing with C rather than D or E, is the same idea. All right, there's something that's happening secretly. So let's get rid of the green. In the body of inc, when you said count plus plus, this is really secretly, because you get this parameter, it's really being turned into this dot count plus plus. Okay, that's how it knows to mess with C stuff, because it's really being passed along as a secret argument. There it is. It's called this. It's being shoved into there, and every line that you use and talk about your object with, it's really being prefixed with the this. That's how it knows how to mess with your own object that you passed to it. All right, that might seem weird. It will make more sense soon, but I do want to tell you that. Now you know. It's secretly what's going on under the hood. Okay, so there's that. And then I think the next thing that I want to show you is a way to get around this init, because that's unfortunate, right? This c.init, we're like forcing ourselves to always call it before we do anything at all to make sure our count is not set to garbage. And what if we forget, right? That's hard. So there's got to be a better way, and there is. So it's called a constructor, all right? Because it will solve this problem. Like, what if I forget to call init? There's a way that lets you never forget, and C++ will do it for you. So it's called a constructor. It's a special kind of method that just gets called for you when your object gets born. So that's perfect. You cannot get around calling this thing called a constructor if you make one. It'll be called for you. That's great. So that'll let us, like, we won't even need an init anymore. It's like the constructor is the initialization. So the way that you make a constructor is, it's just a method. It's a special method, but its name is also special. So instead of, like, if you're inside the counter class, your constructor is called the same name as your class. So it's a method called counter. And you can have multiple different kinds of constructors. You can have one that doesn't take anything, one that takes some stuff, but its name is the same name as your class. So if it was the point class, like, the constructors would be called point in that case. Okay, so for counter, the constructor's name is also called counter. And there also is no return type, no void, no nothing like that. It's like, it's giving back the counter. It's like, it's redundant, I guess. And so there's no even return type for your constructors as well. All right. It's like, maybe it's obvious that, like, you're making a counter, like, you don't have to say counter twice. So that's the thing. You can have as many constructors as you'd like, as long as they differentiate themselves somehow. Like, this one takes a couple parameters, this one doesn't. That's fine. This one's special. The one that takes nothing is special. It's called a default constructor. And so that's the one that's going to happen by default if you don't say otherwise. All right, that's the beauty of that one. So a constructor that takes no parameters is called a default constructor. And so let me show you some constructors for counters. Let's make a default constructor for counters, and then also a one parameter constructor. And I'll show you how to call them, or how they implicitly get called for you. It'll look a little weird as we first learn it, but these are going to be very nice for us. They're going to save our life. So instead of init, no more of that. We're going to make constructors now. All right. So here, let's make a couple. Let's declare a couple. So no more init. Constructors. And so let's make a default one. So it's just called counter, no return type. Counter, parenthesis, parenthesis, semicolon. All right, that's the default constructor. And then we'll do a parameterized constructor. So we'll make one that, like, maybe we want to initialize a counter with a starting count. That'll work. And that's called a parameterized constructor because it takes something. It has a parameter. So those are two constructors, and let's implement them because it kind of makes sense how to implement them, I think. So they're both methods. I guess let's keep them in order. We no longer have init. Goodbye. And then these guys live here. So we've got that one, we've got that one, and it's counter : counter. They're just methods at the end of the day. There's just no return type. It's a little weird. There's that one, and then there's this one. What should we do by default whenever we make a counter if nobody says anything otherwise? That's just init, right? We should just set our counter's count to 0. That's a good initialization. That's a good default initialization for our counter objects. So set the count to 0. For this one, for the parameterized constructor, you can kind of see like what it's saying, like, okay, set the count to whatever the user gives us. Like they're giving us something special. That's how we can initialize. And now the question is, how do you call a constructor? Like, and you're telling me that it's getting called for me. Like, I don't understand. Like, how can I choose which one I want? Here's the secret. Let's scroll on down. I guess here's the constructors. Here's their implementation. I can't show you all of that at once. But let's go down into main. How can you not forget? And how can you choose which one you want? This line right here. This line where you make your counter object, by default, calls the default constructor if there is one. See how great that is? This line, just by itself, by making the counter itself, semicolon, this line calls the default constructor. Does that make sense? Do you see how you cannot forget it now? Like just by making the object, it's going to call the default constructor if you say, unless you called the parameterized one. All right, I'll show you how to do that in a second. But this one's going to call the default constructor. It will be set to 0. Jump up here, set the count to 0. It just does it for you, and everything will work the same as it did. Boop. All the same. Isn't that neat? That's super nice. And now we can do the rest. So like here's, you now may be wondering, how do I call this parameterized constructor then? How do I give something on a line that looks like this? Well, here's how. It looks a little funny. Counter D, if I said counter D semicolon, it would make that counter with the default constructor. It would initialize it, the count to 0. If I want this one, where do I give the starting count parameter? Where do I give the argument? You put it right here after the name. It's a little odd. But that's it. Like set it to 33. That is me calling. It's like you call its name as like a method or a function call. That is where you can call your constructor if it takes something. So that's where I'm passing the starting count. That's a call to the parameterized constructor. You see that? That's really interesting. So that'll hit this one. It'll set the count to 33, and then you're off to the races. You can use your counter now. It's been initialized. D.inc, cout, D.getCount. It'll print 34. Does exactly what you'd expect. Weird, huh? So yeah, those are constructors. Very, very useful. Okay. Next, with the addition of constructors, you get a new kind of syntax. It's called an initializer list. It helps you initialize things because that's what constructors are good for. It's going to answer a few of these questions that you probably don't even have yet, but these are the only ways to do these things. You need this thing called an initializer list, so I have to tell it to you. Okay, so like if you want to construct a member variable in a special way, if you want to have a const member variable, that's possible, but how do you give it its starting value? Well, the answer is this thing called an initializer list. All right, this may not seem important right now, but I promise it eventually will be. So you have to use this thing called an initializer list, and here's what it looks like. It comes before the body of your constructor. All right, what you do is here's your constructor. Maybe it took parameters. Before the body of it, before the curly braces, you put a colon. All right, first thing you do is put a colon, and then like after your parameters are over, you put the colon, and then you start giving these looking things. You say name of your member variables, and then in between parentheses you give calls to the constructors for those member variables. It's very weird. All right, so the way that you create an initializer list, it's part of a constructor. You end the constructor, there it is, and then you put a colon. All right, and then you give these weird looking things. This is the name of your member variable, and then between parentheses you give constructor calls to those member variables. All right, constructor-like calls. So there's a little sad face right there. I guess that's how I remember it. Look for the sad face. That's an initializer list. And yeah, this is weird syntax. And then you have the body after all that. You comma separate all your constructor calls. Okay, so how can you use that? There's a way to use that on ints. Like everything has constructor-like syntax under the hood, believe it or not. Everything you can initialize in this kind of way, even ints. So here's a new piece of syntax. Instead of int x equals 42, I can initialize int x as if it like had a constructor, even though it's not really a class. There is a line that works like this. I could say it like this, int x 42 between parentheses. These two lines are equivalent. That's very weird, but they are. Which means that you could set your member variables, even if they're ints, in this kind of syntax. All right? I promise with an example it'll make a lot more sense, but that's what you need. That's what initializer lists give to you. All right? They let you do some initialization that you could not do otherwise. But we can use it to initialize our ints for fun, even though you don't really need that. So here is our counter constructor. Let's, instead of setting the count to 0 this way, let's set it before the body in this initializer list. So after this parenthesis, I'm going to put a colon, so there's my sad face, and then I'm going to start giving constructor calls to everything. I'll say, well, the name of the member variable, and then what I want it to be set to, count 0 in parentheses. That will do the same thing as this line. Do you see it? It's weird. It's just because this syntax works. You could do that. That will set the count to 0. And so I can do the same for the starting count. So instead of this line, before, in the initializer list, I will use the constructor style syntax to set my count member variable to starting count. Interesting. And nothing has changed. New syntax to do similar stuff, still get the same output. That's pretty cool. By the way, I should also be, how about I do this? Let's output. I'm in the default constructor. And I'm in the parameterized constructor. Just so we can see it happening. I think that would be useful. So here. So now that I'm outputting that, you see what's happening down in main. So here, sorry, I had to scroll to it. So this one, that one called the default constructor, that's the first thing that gets called. Then we set, it initializes it, and then we get our 3, blah, blah, blah. And then when I make this one, that was a call to the parameterized constructor. So it's just one or the other. You don't get both. You only get the one that you called. And then that's why you see that output. So yeah, that was useful to show you, I think. But that's, in addition, initializer lists. That sets member variables. And you didn't have to do it for the count. The count you could have set like this. But there are some things that you can only set using initializer lists. So here are some examples of that. It's like member variables and const member variables. Member variables that are themselves classes that you want to call a special constructor on, not the default, or a const thing. So here's some silly examples of that. Let me include, I guess I need vectors for this example. Let's see here. So let's say for some weird reason inside of my counter class, I want a vector member variable, just for fun. So vector int v, like every counter gets a vector, and then also every counter gets a const double d, all right? These things now are interesting, all right? These things are now interesting. So if I want to, do you remember that there's a way to set vectors, like there's a fill constructor for vectors? I showed you that. So the default constructor for a vector, now I can say these words. If I said vector int v2 or something, semicolon, that starts it off empty. That's what the default constructor for vectors does, because vectors are classes. If I wanted to fill that vector with something, I'd be like, fill it with, I don't know, 142s, 100 copies of the value 42. That's a constructor call. That's a parameterized constructor call to vectors. Do you see it? And so what happens if you don't say anything in the initializer list, your vector v here got default constructed. Did you want that? That depends, all right? So, yeah. If you wanted to construct your vector v in a different way, like with 142s, the body, it's too late. All right, you can't wait until the body. You can do it here though. That's one way to do it. That is the only way to do it actually. All right, for vectors, to construct a member variable using a non-default constructor, that call goes in the initializer list, and then you start comma separating these things. All right, and then finally, another thing that you can only do in the initializer list is if you have a const member variable and you want to set it to something different per object, like d equals 3.14, it's too late in the body of the constructor to do that. It's already read-only at that point. But there is a split second in the initializer list that you could take and use to set your member variable there, your const member variable. You can only do that in the initializer list. Okay, that's where you put it. And so that thing right there, that's your initializer list. Let me mark it. So there. That is your initializer list. That's where it starts. All these comma separated constructor calls. You see it? That's the secret. And so yeah, these kinds of things you can only do in the initializer list. You have options for ints and things, but that's kind of the style that people like to do it with. So these don't belong really in counter, so let's get rid of those. But now you know. There. All right, where were we? So yeah, everything should be the same again now. Got rid of those extra member variables. I'm using the initializer list to set these things though. Just my normal member variables, even though I didn't have to. It's still good practice. All right, so that's initializer lists. What next? What next? I guess I want you to try. So here, using initializer lists now, I'd like you to make, go back to my point example, point class example, or like remake one all over again. Create a constructor on points, remember that one? So that you can do it like this. You can set the x and y member variables of a point object just like this. Point P, and then in the constructor call have a parameterized constructor that took the x and the y and shoved them in to the x and y member variables. So like after this line, what should have happened is it should have been initialized like this. P now holds, or it should hold, x and y being 3.5 and 4.7 apparently. Do you see how you might do that? So yeah, give that a try. All right, so what's the scaffolding here? It's like it's class point, right? Then you give your curly braces, and then eventually closing curly brace and a semicolon. That looks like a 3 though. There. And all right, what's public stuff? Your constructor's got to be public. Public. And then you got your private member variables, right? That's good practice. Your member variables, your x's and y's should all be private. So we'll call that double x and double y. Do it like that. And then now your constructor is going to go here, and you should also implement it outside the class. All right, so let's declare it and implement it just in the slide. So how would you declare a parameterized constructor for points that took two things? Well, its name is point. There is no return type. And then it takes two pieces, right? The two values you want to give for x and y. So it's got to be double, call it like xval, and double yval. Do you see that? That would work. Semicolon. And then let me like go off and implement it like over here. Boop. So how would you implement this now outside the class? It's got to be point, colon, colon, point. And you gave it your two things. You had your double xval, double yval. Double yval. And I want you to use initializer lists to do it. Double yval. And so it's got to be a colon. And then you give constructor calls. The first thing is always your member variables names, and then in between parentheses you give what you want to put into them. That's your constructor style syntax, even for doubles. It's like x becomes xval, and then comma, y becomes yval. Yeah? That's how you do it. And then, because you did it that way, you can have an empty body. So here. Keep it all on this line, I guess. Boop. You now don't need anything in the body because like you've done the setting, you've done every initialization thing you needed to do in the initializer list, but you still need a body. It just has to be empty now. There you go. You see it? That is the secret. All right, that's what you got to do, and that's the style syntax. So it's always this kind of thing. I'll put this on the slide with you. That's the kind of syntax that creates that initializer list. That little sad face. All right. So yeah, I think that is all that I wanted to say for this slide. Couple more things about classes. These are just more advanced concepts now. So I guess in general, let's talk about the word namespace because we've been using that all day long. What does that really mean? All right. Because you also get something with classes. Every class gets its own namespace, and what a namespace is kind of it's kind of self-explanatory. It's just like a space for names. It's a place where you could hold different names, kind of. All right, and the whole point of having these things called namespaces means that you can have, it allows you to have a bunch of things with the same name that don't clash with each other. That's all. That's what namespaces give to you. And so every class gets its own namespace where things can live inside of it. So like when we made our counter class, it's just a type, right? It's just a type. It's like a cloud, I guess. What can you do to a counter? Here. What are the things that live within its namespace that are accessible? It's like you've got ink, you've got like the count member variable, all those things, they live inside the counter namespace. And so actually, this : lets you go inside of a namespace. That's what we've been using it for. It's the apostrophe S. It's really called the scope resolution operator. So there's something involving scopes here, but like that's why we say this. It's like I'm implementing counters ink right now. It belongs to the counter class. I'm resolving scopes right now. That's part of the counter's namespace. It belongs. Ink belongs to the counter type. Okay, that's how we say it. So yeah, in general, you could make another class, and that makes its own namespace, and it lets you have a bunch of things with the same name that don't clash. So like you could make a counter2 class that implements things in a slightly different way, and because it has a different starting name, you can call things ink inside of counter2. You can make an ink method, you can make a count member variable inside of this counter2 class, and it will not clash with the counter class because they're separate places, separate namespaces. All right, let you have a bunch of things with the same name and not have them clash. So that's the key here. Let me underline those words because that's what namespaces let you do. So you have a bunch of things with the same name and have those names not clash. So you don't have to make classes to make namespaces. There's plenty of functions in the standard library that live within this standard namespace, and yeah, you can make your own namespaces. So let me show that to you. And remember, like standard, this namespace standard just means that everything from the standard library lives within the standard namespace, like standard : vector, standard : string. Like that's what we would have had to use if we didn't say this. It's just automatically doing that standard : for us, resolving the namespace. That's pretty cool. So let's see here. I'll make a new file to show you that. So you can just make a namespace with whatever you want in it. That is totally fine. I don't know why that happened. I guess we're good. So here, let's do the following. Let's make two functions called blah and two global variables called x. It definitely won't work just as normal. This is like in the default outer namespace. Like there's one blah function, and then I'll make like int x equals 55, a global x variable, and then here's another blah function. Let's have it return 13, and have another global x member variable that, I don't know, holds 33. This will not even compile right now, because I've redefined things. It's all in the same namespace right now. They're clashing. It's like redefinition. No, you can't do that. You can't have two things with the same name. Sorry. Unless you separate them like with namespaces one way or another. So here's how you do it. You just say the word namespace, give it a name, like I'll call this namespace N1, put some curly braces, and then put whatever you want to live within that namespace. Just a space where things can live. Space where names can live, I guess. This one can be, I guess these can stay in the default outer namespace, that's fine, or you can make a separate namespace for those two. As long as they've been separated somehow, it's happy. And now we're good. Now this program will compile because these are in two different places. The names don't clash. This is N1's blah, this is N1's x, this is N2's blah, N2's x. And you can get them with the colon. So here, now let me keep this on the screen and split it so that we go down to the main. Here's the main function. It's visible, and let's do stuff. Let's use those namespaces. Let's be like, all right, let's call each of those functions, and I'll show you how. All right, it's going to use the : So like, if I want to, if I want to call blah right now, that's not good enough. I have to talk about which blah do I want. Well, I can say I want N1's blah, please. See that? I want N1's x, please. That's how you can differentiate. That's the scope resolution operator. And same for N2. Be like, all right, N2's blah, N2's x, and there's no ambiguity. And I get everything. I get all the things that I wanted here. Bam. Do you see it? So that's namespaces. And so classes are one example of syntax in C++ that just automatically makes a namespace for you. So I guess if you really wanted to, you can make your own version of classes using just like make your own namespace and then like put some structs around there. Like the struct could be holding your member variables, and then you can have functions within that namespace. And that will give you most of what classes do for you, won't it? So that's an interesting little topic. And that's, now you know what the using means. It's like just tack on that standard : at the start of everything. So also, now you also know what the standard library looks like. Secretly, what's going on in the library files is just like everything that the standard library makes for you is just wrapped around this namespace standard. That's what they did. All right. So yeah, I think that's what I wanted to show you for that. Let's go back to classes again, because there's some cool stuff that you can do just when you make your own types. You can make your own operators. I love this fact about C++. So you don't get this ability in Java or some other languages. C++ is great that it lets you do this. So, for example, you can make a plus operation on your counters if you wanted to. Like you can say, if you had two counter objects, you could say C1 plus C2, and it will work as long as you give meaning to that plus operator on counters. Isn't that amazing? That's so cool. Instead of having to do like C1 dot add C2, that you would have to do in other languages like Java, you're forced to do it kind of this way. Disgusting. You could have a plus operator in C++, and I love that. All right. So what happens then? How do you give meaning to the plus? You have to give it's like a method or a function. So when you say this in C++, it goes looking for an implementation of a plus operator on two counters, because that's what you're giving it. So it's going to go looking for either a function or a method called operator plus. That's its name for the plus operator. It's secretly called operator plus. So it's going to go looking for this one or this one, because this is how it wants to call it. It'll either try to call it like a method, C1 dot operator plus with the other thing, or it'll try to call it like a function, operator plus with the two things that you're trying to add. Just like with whichever one you put, it will use. You can't put both. It doesn't have priority. It'll get confused. Like you can only give one, but that's what happens. All right. So yeah, as long as if we want the plus ability on counters, let's just implement one of the ways that we could do operator plus. One of these two ways, either as a method or as a function. Isn't that interesting? I love that fact. So let's say let's first of all be on the same page as to what it means to add counters, because that's a weird idea. So counters have counts inside of them, don't they? So let's say that what it means to add two counters, like if this is count 3, count 4, let's say that if I did this syntax, counter sum equals C plus D. First of all, let's all agree that to add together two counters, it should give back a third counter. And then maybe the summed counter should hold a count that was the summed count. So if it's 3 and 4, let's add the 3 and 4 and make 7 for the sum. Let's say that that's what it means to add two counters. That's that. And now let's implement an operator plus to make that happen. So yeah, you just need one of these, either as a method or as a function. It's going to go looking for an operator plus. That's how it's going to try to call it. All right. So here, how do I want to do this? For example, let's have another separator here. Well, let's do it this way. Let's say I do have a counter D and a counter C right now. That's perfect. Let's sum them up. So counter sum equals C plus D. Like that's what I want to be able to do right now, and I have to give meaning now to the plus. So what C++ will do, it will try to call. It either will try to call it this way, C dot operator plus on D, or it will try to call it as a function, operator plus the function on C and D. It'll go and look for both of them. It'll just call whichever one exists. All right, that's what I want. So I just got to implement one of those ways, and then it will be correct. Then I can output the get count of the sum, and I should see the correct values. All right, so let's give meaning to this. I guess we can do this one. Let's do this one as a method. So let's have it turn it into a C dot operator plus on D. So this will turn it into an operator plus method on the counter class. So up here, let's make this one. It's called operator plus. And if it's going to be called like this, then it only needs one thing because it's implicitly getting ourselves, our current object. That's the left side of the plus, so the right side of the plus is what's being given to us. So it's going to be called operator plus, and it's going to take another counter, counter other, and it'll return a third counter, right? So it'll add ourself with the other counter and return a third counter, all right? So first of all, we're just going to look inside of the other counter. So it should be, let's make it a const reference, save memory, don't mess with it. And then also, we're not going to mess with ourselves either, right? We're just going to look at our own count, add it to the other's count. That's going to give us our third counter's count that we return back. So this can be const, because it's not going to mess with our own object. It's going to create a brand new counter and mess with that count. So it's not messing with our own count. So that's the declaration of the operator. And then we can go and implement it. It'll be called as c.operator plus d. That's what that will turn into. Oops. Because it is a method, it is counter colon operator plus, isn't it? And yeah, let's make it happen now. So what does it mean to add two counters together? We would like to do the following. Let's see here. Well, let's make a brand new counter. Counter result. What do we want to put in that counter? Its count should be our own count plus the other's count, right? And then that's my answer. Return result. That's it. You see it? That will create this and it'll make it happen. Okay? So that's that one. Let's see here. So that's one way to do it, and it will work. All right? If you call C plus D, it'll jump up here, add together those two counts, and it really will make 77, which is apparently, yeah, it's 43 plus 34. That is 77. Cool. It'll jump up here and make the brand new counter and give it back. Isn't that amazing? So yeah, that's option one. That's this way. Let me just show you the function way, because like that's also possible. You can't give both though. So like, let me comment out the one we just did. This is option one. Option one, and then I'll comment this one out. Here's option two. It's mostly the same. If you didn't make it as a method, you could make it as a function. All right, so it would just be a function called operator plus that took two things: const counter, I don't know, C1 and then C2. It'll take the two counters, and then it's just like, all right, my count is C1's count plus C2's count, but actually because this is a function, I can't be doing it like this at all. I have to use like getters. Like it's got to be C1.get count plus C2.get count. And then also it'd have to be like a setter, which I don't really have. So let's use the parameterized constructor on counters to create the correct count initially, just like that. There, that's how you'd have to do it. It would be the function, right? So now it's a function. It's going to call it this way. It'll find this one and add up all the member variables and still do it right, but it's a little more complicated because you can't access private things. This is just a function. That's option two. It'll still work though. Still get my 77. So let's, I'll comment this one out. Oops. Oh gosh. Where was I? I was here. Let's get rid of this one. I'll comment out this one. And let's keep the option one. All right. Keep that kind of operator plus. But you do have options. Could be a function or a method. All right, so now it's back. It's working. And yeah, there's just a bunch of different operators that you could overload. It's called operator overloading. We're giving meaning to operators. You just got to implement it either as a method call or as a function call. All right, so there's a bunch more. Let's do a bunch more. Here's a big table of all the operators that you could overload for your types. So if I zoom in, like you got all these ones. You multiply, divide, subtraction. These comparison operators you can overload, plus equals you can overload, all these bad boys. It's amazing. These kind of operators for like cout and cin, those are useful to overload. And there's plenty more down here somewhere too. Got a bunch of weird ones. Yeah, look at all these. Look at them all. You can negate your class somehow if you want to. Like, what does it mean to test for disequality? All these things. It's amazing. So you have that ability now. Okay, so make use of that. Let me show you a few as examples. Let's do a plus plus operator on counters, because I think that would make the most sense to me right now. Like a plus plus instead of inc, that would work. Then let's do a less than for comparison. That'll also work for sorting. All right, so let me show that to you. So you get a bunch of different operators that you could overload. Operator star, operator less than, operator plus plus. So let's do one of those. Let's do plus plus first. So here, I'll show it to you. Let's say we would like to add a plus plus on counters. That would be great because that would let us do, instead of inking, we could just do plus plus. It's shorter. So let's do it like this. So instead of being like sum.inc, that's too many keys to type. Let's make it be like sum plus plus. For a reason, it's harder to do this one. I'm going to do the prefix plus plus. There's a way to get the plus plus after it, but they're two separate operators. This one's simpler to implement, so I'll show you that one. So it'll be plus plus sum. This will be turned into either a function or a method. Let's make it a method again. It'll be turned into sum dot operator plus plus. That's one thing it'll go looking for. So let's make this one. Just make a plus plus operator inside the type, and then this will get turned into that call, so that you could increment that way. Won't that be fun? So let's make that one. So yeah, it's going to be void. Doesn't give anything back, and it's just operator plus plus. It is definitely not const because it's messing with ourselves, isn't it? So that's a declaration. Then the implementation of that will be, let's go and put it here. It's a method, so counter operator plus plus, and this is the prefix plus plus. That's this way. And what do I want to do whenever it gets called? Increment my counter's count. That's all. And so now by doing that, cool, it made it 79. All right, so instead of this one, let's do the other one. So like they both work. Like now 77 becomes 78 based on this now instead of just the inc. Cool. There's that one. The last one I want to show you is less than. Let's make an operator less than for counters so that we can compare a counter to another counter. And this is useful, for example, for sorting. Let me show this to you in that context. So first of all, let's all agree on what it means to test if two counters are, if one's less than the other. So here, let's make it as a function. So if somebody ever comes and asks, like, hey, is C less than D, that will be turned into a call like this, right? It'll be either C.operator less than D, like that, or operator less than on C and D. All right, so let's do it the function way finally. Let's do it that way. So what does it mean to compare two counters? So first of all, it's called operator less than. It'll take the two counters that we're asking to compare. Counter A, let's make it constant reference. Const reference counter A, counter reference A, const counter reference B. And then what does it mean to compare things? What does it give back if A is less than B or A is not less than B? It's true or false. So it's a bool. That's the return type of operator less than. And then, well, how do you compare two counters? What should it mean? Let's just say that one counter is less than the other, like C is less than D, if the count inside is less than the other counts. All right, so like if 3 is less than 4, if C is less than D in that way, okay? Because 3 is less than 4. Let's say that C is less than D right now, but D is not less than C. So we'll just do a comparison on their inner counts. So that's what it means to compare. So return whether A's count is less than B's count, but this is a function, so I can only use public things. Return whether or not A's count is less than B's count using get count to get those counts. That's it. That will compare. And now you can use them in an if statement if you wanted to. You can compare like C and D if you needed to. A very good use case for the comparison for the operator less than is sorting. All right. So let's say that you come along and you're like, I would like to make a vector of counters, and there's an algorithm function called sort, right? Let's make a vector of counters. I can do that. I got 3 counters right now. I've got sum, I've got C, I've got D, and they are out of order. Let's pretend that ordering means like it's an order of increasing count. So it should have gone C, then D, then sum. So this is completely jumbled right now. I can ask the sort function to sort whatever. I can ask it to sort a vector of counters. And it will be happy because it will go looking for operator less than. That's all it needs to know, like whether one thing comes before another. It'll just keep calling less than. So sort will call operator less than. And so yeah, C less than D turns into either this one, right? C to operator less than on D, or operator less than on C and D. And so that's the one we implemented, okay? And so I guess I don't need to say it twice now. Now you know. All right, that's why we gave it this way. And so sort will go looking for this and it will find it, and now it knows how to order counters. Now we've given meaning to sorting a vector of counters. That's really cool. So now like it's been sorted, and we can let's iterate through every counter in V now that it's been sorted, and it will be that counter's count, right? And that's going to be in sorted order now. So I guess the real sorter should be C, D, then sum. Let's see if we got that. Watch. Look at it. It did sort them. Now sum is at the end of the vector. It's not sum CD anymore. It's CD sum, 34, 43, 78. So it just went and found, used the operator to do the sorting. That's all it needed. That's beautiful and very powerful. All right, we can give meaning to these operators, and it makes code look so much simpler, right? Instead of int, it's plus plus, all this fun stuff. All right, and we get some nice free stuff out of the libraries when we play this game as well, as you see. So I think that is all that I wanted to show you today. So it's a bunch of stuff, very, very useful stuff. I hope you agree. And yeah, that's your first taste of making your own types with classes and making a bunch of objects of those types that you've made. So yeah, it's very powerful. That's object-oriented programming in a nutshell. There's more to it, but this is a good introduction to it, I think. You'll read more about it in your book for sure. And yeah, just ask me lots of questions as you have them. I'd be happy to answer them. But I think that is officially all that I want to say for these slides. So I will see you next time.